traffic lights say turn a blue tomorrow. Shine the emptiness down on my bed. The tiny island sags downstream. 'Cause the life we live is dead.
Hi everyone. So welcome to our second week of class. In this lecture, we're going to be going over thermal cameras and their relationships to drones. This will be the first in our series of technology surveys. Will be where we'll learn about different technologies and how they relate to drones, or we'll be learning about different technologies that are incorporated into drones. So what we're going to talk about first is how thermal imaging works and how thermal cameras sense heat from the environment that they're surveying to create the images that we're familiar with as thermal camera images. And then from there, we're going to be talking about a specific example
The wind cries.
keep going. So after we discuss how the thermal cameras work, we're going to talk about a specific model as an example of how thermal cameras are incorporated into drones. And then we're going to talk about different applications of how thermal cameras are used with drones. And then I'll go over your assignment for this week. So that will be pretty much the whole lecture, all right?
The wind cries.
Alright, to understand how thermal imaging works, the first thing that you have to know about or have a frame of reference for is something called the electromagnetic spectrum, which is how we measure all the different radiation of energy that can be emitted. So things like anywhere from microwaves to ultraviolet rays, these are all part of the electromagnetic spectrum that you may have learned about. Now, infrared or thermal cameras sense these infrared radiations or infrared waves that all of the objects we see around us are emitting. This is different than the visual light spectrum, which is a small fraction of the infrared spectrum. So infrared waves are generally longer. Infrared waves are longer than the visual light spectrum that we see with and that normal cameras work off of. So that's the first thing, is we have to understand what this electromagnetic spectrum is and what different types of radiation are. So all of these objects are emitting energy as heat or temperature, and this is what these thermal cameras are picking up on. So this is a very accurate way of measuring the things around us, because we've developed these sensors that can detect differences in temperature to a very, very small degree. So the way it's measured is not in Fahrenheit or Celsius, but in Kelvin, which is sort of the scientific unit for measuring temperature. So if you've ever heard of the number absolute zero as a temperature, that's 0 Kelvin. So some of these different thermal cameras are able to pick up a difference in temperature to 15 millikelvins, which is, you know, a really small difference.
Scream. Will the wind ever remember?
Alright, so if you want to learn more about how these cameras work exactly and learn about the electromagnetic spectrum more, which I recommend you do. I'll be posting links and videos about this so that you can even learn a little bit about the history of how we discovered these waves that are outside the visual light spectrum. So now I'm going to talk about two different aspects of these thermal cameras that are a little more in detail, but they actually apply to we have to be aware of these things when we're using drones with thermal cameras. So the first thing is called emissivity. Yeah, I think I got that right. Emissivity. And what this is a measurement of is how efficient an object is at emitting thermal energy. So different things have different levels of effectiveness at giving off heat. So they might be the same temperature, but the amount of thermal waves or infrared waves they're emitting can vary, which is sort of tricky to understand. But what this means is that when you're operating a thermal camera, you have to set the emissivity to the object you're trying to measure. Otherwise you'll get an incorrect temperature measurement, which obviously if you're using your drone and you are flying it and the settings off and you get a bad temperature reading, that's going to cause a problem where you then have to bring your drone back in and so on and so forth. Alright, so this measure of emissivity is related to another measure called reflectivity, which is the measure of how much the surface of something reflects thermal energy from the environment around it, from the sun, for instance. So you can imagine a smooth, shiny, black surface like this table is going to have a higher reflectivity than me, which has all these contours and things like this, and is soft and so on. So when we're using a drone, there's a few different things that we have to consider about reflectivity. And the first is actually the angle at which you shoot an object at. If you shoot from too sharp of an angle, some of these reflections of heat can throw off the sensor, where you're actually measuring the reflected heat from whatever it is, the environment, than the actual heat of the object. So if you think about on a hot day, like a metal oil drum, the reflected heat from the sun can cause a temperature reading that's hundreds of degrees different than the actual thing itself. So those are two things that drone pilots have to be aware of when they're operating these camera systems. Alright, now we're going to talk about the way these sensors create an image. So it's important to understand that it's different from a camera, which is picking up the light that we see, and it's also different from other sorts of cameras or visual enhancement systems like night vision you're familiar with, because night vision is just picking up the ambient light, or that it's picking up the ambient visual light and magnifying it. Whereas a thermal camera doesn't need light to function at all. It just needs the heat, and it's only picking up these differences in temperature. So there's two kinds of thermal images you'll see. The first is this grayscale image, which has basically set as white being the hottest and black being absolute zero, and then has as many varying scales of gray in there as possible that create the image. So each different thing has its different heat signature, and that is pixelated literally, so each thing is represented by that certain heat within the grayscale between absolute zero is black and whatever white hot is. Now, the images you might be familiar with or that are more common are these colored images, and all those are, they don't represent, all they are is an artificial projection of color that corresponds with certain heats. So you'll just have a scale of this color equals this range of temperature, and it's mapped onto there. But it's important to know that these are actually less accurate and they're less defined images, these color images, than the grayscale ones. So both are used because of that. One of the things I want you guys to look into are different models of these thermal cameras. So the world leader in this thermal imaging technology is a company that goes by FLIR, F-L-I-R, and they've actually partnered with the leading drone manufacturer, So this company FLIR, or F-L-I-R, I'm not really sure, I've only read the name. They've partnered with DJI, which is the leading drone manufacturer in the world, to come up with compatible systems. So you can buy thermal cameras that you can mount on different drones, and then you can also buy drones which have a ready built system for this thermal application. So I'll be attaching a video for you guys to look into, which is sort of the top of the line model that's out right now, which is called the Zenmuse. So I'll repeat that. So the video will be about the DJI Zenmuse XT2. And so what this drone does is it has a camera system built in that can go back and forth between thermal imaging and 4K HD. So you can kind of use both, and that can be applied in a variety of different ways. So now I'm going to go into talking about the different applications for this thermal technology in the drone world, alright? So one of the first ones is construction. So if you have a construction site, a common way to be able to see if there's malfunctions happening or different pressure systems are leaking, things like this, is by taking a thermal camera and inspecting with it. And so these drones give you the capability of flying your thermal camera above the site and doing your inspection that way, which you might have to, send people up in gurneys to use a thermal camera before. So this can save a lot of costs. A very common one, and I'll post some instances of this working successfully, is in firefighting, where they'll actually use a thermal camera to, when the firefighters respond to the fire, they'll put up a drone with a thermal camera and use it to get, read hot spots to see if they can go in, where would be the best place to go in, these sorts of things. Now, the last application that I'm going to talk to you guys about is sort of controversial and one that I think is very interesting. So it can be used throughout surveillance. So you can imagine that there's been, for a number of years now, military applications of this thermal technology. But now what we might see is surveillance of our own populations using this thermal technology, particularly for this coronavirus response. So I've seen, and I'll post you guys links to this as well, software is being developed where they're going to be using these thermal cameras to measure people's core body temperatures. So you can imagine a situation where there's a crowd of people and you have a drone overhead that's measuring people's core body temperatures to see whether or not they have a fever. Now, you know, this starts to, for someone like me who's interested in these sorts of issues about, let's say, privacy versus security, this is the type of application that might have an effect there. Those are the different applications of thermal cameras for drones. There could be more, those are just 3. And a basic review of the technology, how it works, how it can be equipped to drones, and that's it for this week. So I'll be posting details about the assignment for this lecture, but the gist of it will be that you'll be creating a Flipgrid response based on what you've heard and based on the different articles that I post, so you can respond to any one of them, or you can come up with a creative scenario using your pilot code name and a situation where they're operating a drone with a thermal camera. So you might have them at a coal mining site, you might have them on the scene of a fire, you might have them surveilling some people. So you can be creative with it, or if you want, you can just respond to one of the articles or videos that I post. And I'll leave detailed instructions on Google Classroom. Alright, I'll see you guys for the next lesson. Thank you.
Will the wind ever remember